Hi everyone, and welcome to this video going over our Unit 5 exam study guide. Across the top I have our perfect squares because the first thing we will be doing is simplifying our radicals. And we simplify radicals by looking for two numbers that multiply to the number on the inside where at least one of them is a perfect square. So for example, I have 80, and in order to check which perfect squares divide 80, you can go in order. 80 divided by 4. And when you do 80 divided by 4, you'll get 20. Our perfect square is 4. The square root of 4 is 2. And then make sure you check to see if the other number can be divided by any more perfect squares. So then I'll check 20 divided by 4. And I'll get 5, which means that 4 times 5 is 20. Once again, 4 is a perfect square. The square root of 4 is 2. And then I check 5. 5 cannot be divided by any perfect squares. So 5 is going to stay on the inside. And notice how I have two numbers on the outside. Whatever numbers get brought to the outside, you multiply together. 2 times 2 is going to get me 4 for the outside. Let's try number 3. I'm going to ignore the 9 for right now and just focus on simplifying my 72. I'm going to go in order to check which perfect squares divide 72. So I'll try 72 divided by 4, and I get 18. 4 is my perfect square. The square root of 4 is 2. And then I check if 18 can be divided by any perfect squares. So I'll try 18 divided by 4, and I get a decimal. I'll then try 18 divided by 9, and I get 2. 9 is my perfect square. The square root of 9 is 3. And 2 cannot be simplified any further. So 2 stays on the inside, and all of the numbers that I have on the outside, including that 9, get multiplied together. 9 times 2 times 3 will get me 54 for the outside of my radical. Now let's talk about adding and subtracting radicals. We can only add and subtract radicals that have the same inside. So for example, in number 5, do you see how both terms have radical 3 and radical 3? That means I can combine them. Negative 3 minus 3 will get me negative 6, and the inside stays the same. Looking at number 6, once again, I have radical 6 and radical 6, so I can combine these. 2 minus 3 gets me negative 1, and the inside stays the same. And whenever we have a 1, it can be imaginary, so we can also write our answer as just negative radical 6. For 7 and 8, make sure that you simplify your radicals before adding or subtracting. For example, I can simplify radical 54. Radical 54 can be divided by 9. 9 times 6. The square root of 9 is 3. And 6 cannot be simplified any further. So 6 stays on the inside. And I'm going to multiply my negative 2 and my 3 together to get negative 6. So now that they're the same radical, I can combine them. Remember, there's an imaginary 1 here, so negative 6 minus 1 gets me negative 7 radical 6. And then looking at number 9, please make sure that you only combine the radicals that have the same insides. So for example, I can only combine the negative 3 radical 3 and the negative 2 radical 3 to get negative 5 radical 3. And then I just copy down the 2 radical 5 since it couldn't be combined with anything else. Now let's talk about multiplying radicals. When you multiply radicals, you keep the outsides separate from the insides. So for number 11, I'm going to multiply negative 2 and 2 to get negative 4. And then I'm going to multiply 24 and 6 to get 144. Notice how I said make sure your final answer is simplified. So looking at my radical, I know that 144 is a perfect square. The square root of 144 is 12. So this is going to turn into -4 times 12, since that -4 was being multiplied by the radical, and the radical turned into 12, and -4 times 12 will get my final answer of -48. Let's try number 12. Remember, there's an imaginary 1 in front of that radical 10. So 1 times -4 gets me -4. And then to multiply the insides, I have 10 times 2, which is 20. And then I see if I can simplify my radical. And I can, because 20 can be divided by 4. The square root of 4 is 2. And then I check if 5 can be simplified any further, and it can't. So 5 stays on the inside. And I'm going to multiply that 2 with that -4 that was also on the outside. And that leaves me with -8 radical 5. Now let's move on to talking about dividing. Same thing with multiplying. When we divide radicals, we keep the outsides separate from the insides. So for number 15, there's an imaginary 1 in front of that radical 4. 2 divided by 1 is just 2. And then we divide the insides. 20 divided by 4 is radical 5. For 16, I noticed that 16 is a perfect square. The square root of 16 is just 4. So this is going to turn into radical 8 over 4. And I'm going to check to see if radical 8 can be simplified. And it can. 8 can be divided by 4, which is a perfect square. The square root of 4 is 2. And 2 cannot be simplified any further. So this radical 8 is going to turn into 2 radical 2 over 4. And since this 2 and this 4 are both on the outside, I can simplify them. Let's think about a number that divides both 2 and 4. I know that 2 divides 2 and 4. 2 divided by 2 will give me 1, and 4 divided by 2 will give me 2. So my final answer is going to be radical 2 over 2. Looking at number 17, 5 does not divide 2. But there's a math law that I cannot leave a radical in my denominator. So we are going to do what's called rationalizing the denominator. Rationalizing the denominator means I'm going to multiply the top and the bottom of my fraction by radical 5. And remember, for the top, since that 5 is inside the radical, it's only going to get multiplied to the 2. So that 4 is still going to be in the front, and 2 times 5 is 10. For the denominator, 5 times 5 is 25, and 25 is a perfect square. The square root of 25 is 5. So notice, by multiplying the top and the bottom by radical 5, I no longer have a radical in my denominator. Then I check if there's any more simplifying I can do, but 4 and 5 have no common factors, and so this is my final answer, 4 radical 10 over 5. Let's also try 18. Once again, I can't leave a radical in my denominator, so I'm going to multiply the top and the bottom by radical 2. Since that 2 is outside and the other 2 is on the inside, I can't multiply them, so they just get put right next to each other. And radical 2 times radical 2 is radical 4. And 4 is a perfect square. The square root of 4 is 2. So this turns into 2 radical 2 over 2. Notice how I no longer have a radical in my denominator. And since there's a 2 on the top and on the bottom, those can cancel out, leaving me with just radical 2. Now let's move on to review our factoring. Looking at number 19, when you start factoring, the first thing you should look for is a GCF, a greatest common factor. I noticed that both of these terms can be divided by x. X squared divided by x is x, and negative 4x divided by x will just be 4. And don't forget to write your greatest common factor on the outside. Solving means finding your x-intercepts, and our x-intercepts occur where y equals 0. So after you factor, you set each of your factors equal to 0. So I'm going to set x equal to 0 and x minus 4 equal to 0 and solve. Well, x equals 0 is already solved. So 0 is one of my x-intercepts. And then for my other factor, to get rid of minus 4, I add 4 to both sides. And this means that 4 is my other x-intercept. Looking at number 20, there doesn't appear to be a GCF. This is not a difference of squares, which means this is my magic x. My a is 1, my b is 6, and my c is 5. So on top of my magic x, 1 times 5 is 5, and on the bottom is 6. I'm looking for two numbers that multiply to 5 and add to 6. I come up with 5 and 1. Then we put our a value on top, and we create our factors. This means that my factors are going to be x plus 5 and x plus 1. And lastly, we're going to solve each for 0. To get rid of adding 5, I subtract 5. So I have x equals negative 5. And to get rid of adding 1, I subtract 1. My other x-intercept is going to be negative 1. Let's try a few more. So moving on to number 21, there is no greatest common factor, but this is a difference of squares. Our difference of squares is when we have two perfect squares separated by a minus. So I'm going to square root both of my terms. The square root of x squared is x, and the square root of 16 is 4. So this means that my two factors are going to be x plus 4 and x minus 4. And then we solve each for 0. Here I subtract 4, so I have x equals negative 4. And here I add 4 and get x equals positive 4. Let's do one more. In 22, notice how my equation equals negative 3. Before solving, we need to make sure that our equation equals 0, because if we're trying to find our x-intercepts occur where y equals 0. So in order to move that negative 3 to the other side, I'm going to add 3. And then I'm left with n squared minus 6n minus 16 equals 0. And now I factor. There's no GCF. This is not a difference of squares. So this is going to be magic x. My a is 1, my b is negative 6, and my c is negative 16. 1 times negative 16 is negative 16, and I'll have negative 6 on the bottom. Two numbers that multiply to negative 16 and add to negative 6 are going to be negative 8 and positive 2. I then put my a value on top. So my factors will be x minus 8 and x plus 2. And then we set each equal to 0. I'm going to add 8 to both sides. And then subtract 2 to both sides. So my x-intercepts are positive 8 and negative 2. So before you solve and factor, please, please, please make sure that your equation equals 0. Now let's talk about solving by taking square roots. In number 25, I have n squared equals negative 36. To get rid of the square, I square root. But remember, we can't take the square root of a negative number. So if you ever notice that you have a negative number in your square root, all you have to write are no real solutions. Looking at 26, I'm going to square root to get rid of the square. And 36 is a perfect square. The square root of 36 is 6, because 6 times 6 is 36. But also remember that my answer could be negative 6, since negative 6 times negative 6 is also positive 36. So we have two solutions, positive 6 and negative 6. Looking at number 27, before we square root, we have to get the term with the square by itself, which means I'm going to subtract 6 first. So I have m squared equals 0. And then I'm going to square root. The square root of 0 is just 0. And since there's no such thing as negative 0, this means I only have one solution. Looking at 28, same thing, I need to get rid of that 9 first, so I'm going to subtract 9 to both sides, and I'm left with n squared is equal to 17. To get rid of the square, I square root both sides. And 17 is not a perfect square, and it doesn't have any perfect squares to divide it, so I'm just going to leave 17 in the square root. And I'm going to put the plus minus symbol on the outside to show that my answer could be positive radical 17 or negative radical 17, which means I have two solutions. In number 29 and 30, I am also using square roots to solve, and we need to make sure that our parentheses with the square are the only things on that side before we square root. So notice how the 2x plus 4 squared is the only thing on the left side. So now I'm going to square root to get rid of the square. The square root of 100 is 10, but it could also be negative 10. So I need to solve this twice, once for positive 10 and once for negative 10. I'm going to start by subtracting 4 to both sides, and I get that 2x is equal to 6. And then I divide by 2, and I get 6 divided by 2 is equal to 3. Solving the other side, once again, I'm going to subtract 4 first, and I get 2x is equal to negative 14. And then I divide by 2, and I get that x is equal to negative 7. Let's try number 30. I have to get the parentheses squared by itself before I square root, which means I need to add 3 to both sides. And I get p plus 1 squared is equal to 25. And now that the parentheses squared is by itself, now I can square root. The square root of 25 is 5, but it could also be negative 5. So I have to solve this twice. To get rid of adding 1, I subtract 1. So I get that p is equal to 4. And subtracting 1 on the other side, I get p is equal to negative 6. Now let's try solving with the quadratic formula. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to start by labeling my a, b, and c values. A is 2, B is 6, and C is negative 108. And I'm going to plug these into my quadratic formula. So I have negative my B, which is 6, plus or minus 6 squared, minus 4 times A, which is 2, times C, which is negative 108, all divided by 2 times a, which is 2. Negative times 6 is negative 6. And if you use a calculator and plug in all of the stuff inside the radical, you will get 900. And 2 times 2 is 4. If you use your calculator, 900 is a perfect square. The square root of 900 is 30. So I'm left with negative 6 plus or minus 30 divided by 4. And remember, this is two answers. I could have negative 6 plus 30 divided by 4, or negative 6 minus 30 divided by 4. Negative 6 plus 30 is 24. Divided by 4 gets me 6. And negative 6 minus 30 is negative 36. Divided by 4 is negative 9. So my solutions are 6 and negative 9. Let's try 34. Notice how in 34 my equation equals 8. Like I've said before, we have to get our equation equal to 0 because our x-intercepts occur where y equals 0. So to move the 8, I'm going to subtract 8 to both sides. And I'm left with b squared plus 6b minus 27 equals 0. And now I can label my a, b, and c values and plug these values into the quadratic formula. X is equal to negative b, which is 6, plus or minus b squared, so 6 squared, minus 4 times a, which is 1, times c, which is negative 27, all divided by 2 times a, which is 1. Negative times 6 is negative 6. And if we use our calculator to plug in what's inside the radical, we get 144. 2 times 1 is 2. And 144 is a perfect square. The square root of 144 is 12. And remember, this means we have two solutions. Negative 6 plus 12 divided by 2, and negative 6 minus 12 divided by 2. Negative 6 plus 12 is 6, divided by 2 is 3. And negative 6 minus 12 is negative 18, divided by 2 is negative 9. So with the quadratic formula, make sure you label your a, b, and c values correctly when your equation equals 0, and use your calculator to plug in step by step until you get your two solutions. Next, for 35 and 36, find the x-coordinate of the vertex. We use the formula x equals negative b over 2a. This tells us the x-coordinate of the vertex. It also tells us the axis of symmetry, since the axis of symmetry goes through the vertex. So labeling my a, b, and c, my a is negative 1, my b is 4, and my c is negative 8. And I'm plugging in my values. So negative b means negative 4, divided by 2 times a, which is negative 1. So I'll have negative 4 on top. 2 times negative 1 is negative 2. And negative 4 divided by negative 2 is 2. Let's try this one more time. So labeling my a, b, and c values. A is negative 2, b is 8, and c is negative 6. So I'll have x equals negative 8 divided by 2 times negative 2. So I'll have negative 8 on top. 2 times negative 2 is negative 4. And negative 8 divided by negative 4 is positive 2. So using this, now let's see how we graph quadratic functions. Sketch the graph of each function by finding the axis of symmetry, the vertex, and the x-intercepts. So starting with 37, I'm going to label my a, b, and c values. My A is -1, my B is 4, and notice how I don't have a number being added or subtracted at the end, which means my C value is 0. I'm going to start by finding my axis of symmetry using that x equals -b over 2a. So my b is 4, so I have -4 divided by 2 times -1. So I have -4 divided by -2, which means my axis of symmetry is the line x equals 2. This also means that my vertex has the x value of 2. And now I just need to figure out the y value. And we do this by plugging in the x value into the function. So I'm going to plug in 2 for x in my equation. And you can type this into your calculator. So negative parentheses 2, parentheses squared, plus 4, parentheses 2. And you should get 4, which means my vertex is the point 2, 4. And the last thing I need to graph my function is my x-intercepts, and we get that by factoring. So I'm going to write down my function, -x squared plus 4x. And in order to factor, the first thing I'm looking for is a greatest common factor. And I notice that both of these terms can be divided by x. -x squared divided by x is just -x. And 4x divided by x is just 4. And I write the GCF on the outside. Once you have your factors, we're going to set each factor equal to 0. So I'm going to say x equals 0 and -x plus 4 equals 0. X equals 0 is already solved. That means one of my x-intercepts is 0. Now to solve the other equation, I'm going to subtract 4 to both sides. And I get -x equals -4. And imagine that negative in front of the x is a -1. To get rid of that -1, I'm going to divide by -1 to both sides. And I get x is equal to 4. So 4 is my other x-intercept, and I graph my parabola. Let's try this one more time. So step 1, I'm going to find my axis of symmetry using x equals -b over 2a. So labeling my a, b, and c values, a is -1, b is -6, and c is -5. So plugging this in, I have -6 divided by 2 times -1. Whenever I have two negatives right next to each other, that turns into a positive. And then 2 times -1 is -2. 6 divided by -2 is -3. So my axis of symmetry is the line x equals -3. This also means that my vertex is -3 something. And in order to figure out that y value, I'm going to plug -3 into my function. So -3 squared minus 6 times -3 minus 5. Plugging this into my calculator, I get 4. So this means that my vertex is -3, 4. And the last thing we need is to factor to find our x-intercepts. But remember, we cannot use magic x if our a value is negative. So we need to factor out this negative. So I'm going to divide all of my terms by -1. So I'll be left with positive x squared, positive 6x, and positive 5. I'm going to write the -1 on the outside as if it were a GCF. And now I can do magic x. Now my a value is positive 1, my b is positive 6, and my c is positive 5. 1 times 5 is 5, and I put 6 on the bottom. Two numbers that multiply to 5 and add to 6 are 5 and 1. Then I put my a value on top, and my factors are x plus 5 and x plus 1. And I solve each for 0. So x plus 5 equals 0, and x plus 1 equals 0. I subtract 5 to both sides, and I get x equals negative 5. And I subtract 1 to both sides, and I get x is equal to negative 1. So my x-intercepts are negative 1 and negative 5, and here is my parabola. So your steps for graphing are: step 1, find your axis of symmetry using that x equals negative b over 2a. Then that also tells you the x value of the vertex, which you then plug into your function to find your y value, and then you factor to find your x-intercepts. Hopefully this gives you a very good head start on your study guide. Please let me know if you have any questions, and I'll see you in class.